Hey folks, happy Tuesday. Again, sorry I couldn't be here. Hopefully this video will suffice. Even though I'm not here, you get to listen to Mr. Heinrich talk. Yay! Isn't that exciting? If you want to grab your notes from last day, grab yourself your periodic table. Let's actually start with a quick review of what we looked at last day. And that was, it was all about ionic compounds. And what we need to remember about ionic compounds is that it's all about two things joining together. And I know maybe you're not saying it out loud because I'm not here, but you're thinking it in your head. It's all about a metal pairing up with a nonmetal. So something from the left-hand side of the staircase, that's your metal, joining up with something from the right-hand side of the staircase. So let's go back and just take a look at writing some formulas. This is what we practiced yesterday, but let's make sure that we still remember what the heck was going on. Remember that we need to, I won't write this down, we just wrote it down, kind of, sort of. But it's always the metal first and then the nonmetal second. Just like how we always think ionic, metal, and nonmetal, because that's the order that they always form in. Or the order we always write them down in, I should say. So let's look at formulas. Let's try, maybe I'll just go to names, because we finished off last day looking at names. Let's do cesium. Let's go cesium chloride to start. So remember, what I want you to do, humor me and at least show me what the symbols are with their ion charges, because you have to look that up anyway. So if you head to your periodic table, I won't flash one up here just because it's hard with the video to switch back and forth. But cesium is atomic number 55. So it's Cs. And it forms an ion charge of +1. And it's going to join up with some chlorine. Remember, chloride just means chlorine. We'll talk about naming in just a moment. And chlorine, you'll see, forms an ion charge of -1. We don't show the ones. And then we talked about doing this swap and drop, how you take those ion charges and you swap them to the other element, and we drop them down into subscripts. So how many of each of these elements do we end up with? That's what we're trying to figure out, is how many of each do we need to balance the charges. Well, cesium, this was a -1. So we dropped a 1 down, but we don't show ones. So we actually just leave it as cesium with no number. That represents 1. And then chlorine, we see here that we're swapping a +1. We drop it down. Remember, we do drop the charges as well in swap and drop. So that would be a 1 as well, but we don't show ones. So final answer, CsCl, cesium chloride. Let's try another one. Whoops, there we go. Let's go scandium nitride. Scandium, if you're having trouble finding it, is atomic number 21. So scandium is Sc, and if you look at the ion charge on your periodic table, it's a +3 or 3+. And then we're going to swap and drop that with nitride, which is actually just nitrogen. And nitrogen, you'll see over in your nonmetals, atomic number 7, has a charge of -3. So we're going to swap that over. And some of you remember what we need to do here. Again, maybe you're not shouting it out loud, but hopefully you're thinking of it in your brain, that we're going to swap those SC, so we've dropped over a 3. And then the nitrogen, we've swapped over and dropped another 3. But remember that if possible, and you have to look for this, number one thing that students forget to do is we look to reduce if we can. So in this case, each of these subscripts is divisible by 3. So 3 divided by 3 is 1, and then we don't show that. So scandium, there's only one of them joining up with every one single nitrogen. So there's your final answer for that one. There it was for the first one. So again, always look to do that reduction. Maybe let me do one more with where we have to reduce. Let's go. What do we have? I'm trying to find something. Oh, here's a different one. We haven't done this one. Hafnium. And let's swap that with oxide. There we go. So hafnium is atomic number 72. So if you go and find that on your periodic table, hafnium's symbol is HF with a charge of +4 or 4+, it doesn't matter. So there's your hafnium. Oxide is just oxygen, which is a -2. So we're going to swap and drop, take those charges, cross them over, lose the plus and the minus. And some of you, let's stick with blue. Some of you might be comfortable doing the reducing in one step. If that's the case, awesome. Go for it. I'll show the long way, I guess. HF, notice we're dropping down a 2 onto the hafnium. And then onto the oxygen, we're dropping down the 4. But that can be reduced. 2s and 4s, both divisible by 2. So what we need to do is divide each of those by 2. So 2 divided by 2 is 1. Remember, we don't show 1s, so we get to leave hafnium just as is. And then for oxygen, 4 divided by 2 is 2. So that is your final formula for hafnium oxide. All right, so that was the writing formulas. Let's look at just some basic naming. And we have a bunch of people that I think might have done this already yesterday. If that was you, well done. If it wasn't, that's okay. It's not hard. You actually kind of know the drill already because we've been working with names. So for ionic naming, remember we're talking about metals and nonmetals. It always goes in that order. And again, I know I've said this a million times already. I'm going to keep saying it. It's really important we remember that ionic bonds are metals and nonmetals. And then when we go to do names, it's actually not a hard drill, not to start anyway. What we need to remember is that the metal, the name is just normal. Like right off your periodic table, normal name. So that's what we do with the metal. So something like hafnium stays as hafnium. So that's not hard. But for the nonmetal, what we need to do is we drop the normal ending and we add the IDE ending. And what is sometimes tricky is to tell where you do the cutoff of the regular name to add the IDE ending. So notice, like for oxygen, we don't call it oxygenide. We don't write the full name and then add the IDE. We actually chop off some of the name and tack on the IDE. If you're ever unsure of where to cut the name off, just do your best, because as long as I can tell that you remember the rule, then that is A-okay with me. So let me give you a couple of examples here. I think you'll catch on to this pretty quick. Let's go with LIBR. So from the formula, remember the metal is always first. So that's kind of nice. So Li, you just have to look up its name on your periodic table. Nothing changes about the metal. Remember we said it's the normal name. So Li is simply lithium. It's a good station, rock station on Sirius XM if you know what I'm talking about. And then Br, if you look that up on your periodic table, that's bromine. But we don't call it bromine, and we're not going to call it bromine-ide, because that just doesn't roll off the tongue nicely. So we chop off the INE ending, bromine, and we simply change it to bromide. So notice that non-metal became IDE. Let's try another one. Let's go SCI3. So this is just a simple ionic compound, a metal and a nonmetal. And if you go and look on your periodic table, Sc is scandium. Like Scandia in Kelowna, if you've ever been there. Lots of cool arcade games and sort of carnival games. So that's scandium. And then we've got I, which is iodine. So we're going to add the IDE ending. Again, not to call it iodine-ide, because that's hard to say. It simply becomes iodide. And there's that IDE ending. Okay, let me flash another one up here and see if you can get it before I put the name up. Let's do a short one. Let's go sodium. That's a good one. So let's go Na3P. So trying to come up with some shorter names for you. So sodium is a metal, Na. So you know that right away is an ionic compound. So we get to do this naming drill. So Na, sodium, name it as normal, right off the periodic table. And then you have to figure out what the P is. P is phosphorus. So that's one where it might be a little bit tricky to tell what the cutoff is or where to cut it off. Phosphorus becomes phosphide. And you don't have to copy this down necessarily, but let me just show you a few other ones. So you have something like sulfur. If we had to do the IDE ending, would be sulfide. And if you had something like, what do we have? Oh, what about tellurium? That's atomic number 52. That would become telluride. So notice it's all about cutting off some of the name and adding an IDE. Actually, I think Telluride, isn't that like a town in Colorado, a ski town, I think. Nitrogen becomes nitride. And like I say, you'll get used to these names just by doing a bunch of practice. So that goes with, I won't give you time to do this quite yet. I want to show you one other thing. But that goes with the worksheet I gave you yesterday. There are extra copies sitting on the desk with the TOC. That goes with that nomenclature packet. Worksheet 1, number 1. It says name the following ionic compounds, and it's A through J on that first piece of paper. So you can try that out after if you didn't get to it yesterday. Okay, one more topic then before we turn you loose to try out some more of that worksheet. Let's look at multivalent metals. So this is still ionic compounds. But you might remember, I think we mentioned these multivalent metals. They are multivalent metals. So this is a special case. Remember, these multivalent metals are the ones that have multiple ion charges. And they typically show up in the middle of your periodic table. So if you want to look at your periodic table right now, I'm talking about, look in the middle, basically starts, there's a whole bunch of them starting like at 22, like titanium, vanadium, chromium, manganese has 3 different ions that it forms. So you'll notice there's a bunch of the metals in there that form different ion charges. When we go to do the names of these things, the name tells you which ion charge to use. And it tells you that with, so the name contains Roman numerals. And we'll do a quick review of those. Roman numerals. To reveal or to tell you the ion charge. Because we have to know if we used like iron 3+ or did we use iron 2+. And the name is actually going to tell you that. So let's do a quick review on the Roman numerals just in case you don't remember them. I think for charges, what do we need? I don't know. We don't really go. I guess there's rhenium is a 7+. Let's go up to 7 then. I don't think we need to go past that. So here's how your Roman numerals go. 1, 2, 3, 4, 5, 6. Well, I'll go to 8 just for fun. Okay, so there's our regular numbers. And then the Roman numerals I'll put right beside them in pink. So the number 1 is like an I. Some people put tops and bottoms on, or it's sometimes just a single line like that. It doesn't really matter. So that's 1. 2 is 2 of them. You may wish to put the lines on top, or you can just write it like that. And I'll totally give you creative control. You go and do whichever one you want. 3 is 3 lines. You can put the top on or not. I don't really care. Looks like a tally so far. Now what I'm actually going to do is skip to 5. 5 is a V. And again, you can put the top on or not. I'll just show both. So there's 5. That one actually looks a little bit nicer, probably just as a V. Now 4 is 1 before 5. So that's how they work these numbers. I think that's kind of cool. So 4 is IV, 1 before 5. Or like that. 6 is 1 after 5, or 5 plus 1. So it's VI. Right? 5 plus 1. This was like 1 before 5. 7 is 5 and another 2. 2 after 5. You do it like that. And then 8 is simply 3 after 5. VII. So it's kind of cool that the name tells you which ion charge you're dealing with. So let's do some formulas then. I'll show you with the names how this works. It's actually pretty darn easy as long as you remember your Roman numerals, and you'll have those in no time. So let's do some formulas. And really all you need to do for formulas is just remember to use your Roman numerals. Use RomNum. Let's be efficient. Use your Roman numerals. And then we do swap and drop after that. So let's try a few examples here. Let's do, I was talking about iron before. So let's go iron, like that. I won't mention what it is yet. Some iron fluoride. So notice we've got some Roman numerals in there. We're going to use that to figure out what the charge is on the iron so that we can do swap and drop. So iron is atomic number 26. The symbol is Fe. And you'll notice that it could form an ion charge of 3+, or it could form an ion charge of 2+. In this case, the name tells you that we went with the 2+ version. That's how easy that is. It's kind of cool. You don't even have to look up the ion charge because the Roman numeral tells you the ion charge on that multivalent metal. And then fluoride is simply just a fluorine. Remember, we always put the IDE ending. If you look at your periodic table, it has a charge of minus. And then we're going to swap and drop those ion charges. So we cross those over. Now it's business as usual. So that is going to give us Fe1, because this was a -1 that crossed over, but we don't show the 1. And then F, we swapped over a 2. We don't have to worry about reducing any of that. Oops, let's get rid of that line. There we go. Final answer, Fe, F2. So the Roman numerals are pretty slick. I will throw a few more in here. Let's do this one. Nickel. With that Roman numeral. And nitride. Nickel's atomic number 28. So you might have to hit your periodic table to see just what the symbol is. The symbol is Ni. And then it's cool, the ion charge, what am I going with? Well, the Roman numeral tells me. That's the Roman numeral 3. So this is going to be nickel with a 3+ charge, joining up with nitride is nitrogen with a -3 charge. Oh, some of you know what we have to do. Remember what we do if there's 3s. We're going to swap and drop. We get Ni. We cross over a 3. And N, we've swapped over a 3. But hey, we can reduce. If there's a pair of 3s, each of those is divisible by 3. So that becomes Ni1 and then N1. We don't show the 1s. And that could be like 9 Inch Nails to keep the music theme going. Rock band of my youth. Okay, let's try one more. I want you to see if you can race ahead of me and get this one before I put the answer up there. Let's go copper with that Roman numeral. Arsenide. So you hit your periodic table to look up the symbol for copper. It is Cu. But the name tells you right away what the ion charge is. We know it's simply +1. Arsenide is our nonmetal. That's arsenic, which is As. and it has a charge of -3. And now we're at business as usual. Swap and drop that. Our formula becomes Cu with a 3. And then arsenic is As, and that's simply just a 1, which we don't show. Final answer. All right, so hopefully that's so far so good. We're going to tackle one more quick thing looking at multivalent metals, and that is working the other way. If I give you a formula, can you tell me what the name is? All right, the last part of today's game is what if we have to do names with multivalent metals? Multivalent metals. So this is sometimes easy, and then it can get a little bit tricky where we just have to think a bit, which is good. You got to use your brain. What we're going to do with multivalent metals is we're going to do a reverse swap and drop. So we actually have to undo the swap and drop. Because what we have to do is we have to figure out which ion charge was used in that compound. And sometimes it's really easy to see, and other times it's a little bit trickier. So let's try a couple of examples. I'll show you what the reverse swap and drop looks like. Let's go with this one. Ti F3. So let's try that. So let's undo this swap and drop, which is actually kind of weird. So looking at this formula, where did the 3 come from? Well, it appears the 3 would have dropped over from the titanium. So that actually is going to go back on the titanium. That shows its ion charge. And then notice that there's nothing on the titanium. That actually means a 1. So if we undo that, it sure looks like it came off the fluorine. So doing the opposite of what we've been doing for the first sort of day and a half here, it looks like titanium was a +3. Remember, the metals are always positives. So if we undo this swap and drop, titanium is a +3. And fluorine is just a -. Now what you have to go and do is make sure that we haven't reduced anything. That's where it gets a little bit tricky. And in order to tell if the thing has been reduced, I want you to go to your non-metal. So if you look on your periodic table at fluorine, you will notice that its ion charge, according to your periodic table, is simply just -1. So that means life is good. It has not been reduced. Then go check out titanium, which is atomic number 22, and make sure that +3 is one of the options. And you'll see that titanium could have been a 4+ or a 3+. So you can say, hey, that checks out too. Fluorine does indeed have a charge of -1, and one of the possible charges for titanium is indeed +3. So now when we go to name this thing, we're going to use our regular naming rules. This is titanium. But now we have to put in brackets the Roman numerals to tell people which ion charge we use. So that's 3. 1, 2, 3. And then what have we got here? It's a fluorine. So remember, we don't call it fluorine. We have to add that IDE ending, like always. So that becomes titanium fluoride. So we have to remember with these multivalent metals to get that ion charge in brackets. So that's what they look like when they're sort of more straightforward. Let me give you another one and see if you can figure out what's going on here. Let's go with this one. COS. Some cobalt and some sulfur. So you go and you look at your periodic table. Cobalt is number 27, pretty much smack dab in the middle. Oh, and you go, geez, it's multivalent. That means we have to undo the swap and drop. And you look here and you go, well, it's kind of just ones. Like there's a 1, because we don't show ones, even though they're technically there. Weird chemists. There's a 1. So, geez, it looks like this is cobalt. Remember, the metals are always positive. So it looks like it was cobalt with a charge of +1. Swapping and dropping with sulfur, which is a -1. Now go look at your periodic table. You're going to find something weird. You're going to go, uh-oh. Sulfur doesn't actually have a charge of -1. Sulfur's real charge is -2. And it's only got that one charge. That means it's always a -2. So why the heck did we make it a 1 then? Well, that means we've reduced, right? If all of a sudden the number has become smaller, that's because we had reduced in there. So now we're, again, going backwards. We have to, unreduce it. We need to undo the reducing. So if sulfur was a -2, that means cobalt, in order for this to just be a pair of 1s, actually had to have been a +2. And then remember, when we swap and drop the 2s, they would simply cancel out and become nothing. So in this case, you can now go and double check. You can say, okay, sulfur is actually a -2, and is +2 an option for cobalt? Indeed it is. So now we can name this thing. It is cobalt. We used the ion charge of 2, so we have to show that, Roman numeral in brackets. And then it was sulfur, but that becomes sulfide. Always tack on that IDE ending. Okay, let me give you one more trickier one. Let's try. Again, looking for shorter names. Let's go with this one. OS SE2. Okay, so you look at your periodic table. OS is osmium. It is 76. Towards the middle again. And you go, geez, that's multivalent. That means we're going to have to figure out the ion charge. We have to do the reverse, swap and drop. So swap and drop backwards. It's going to do that. And if we look at what we're left with, we've got an osmium and a selenium. That 2 looks like it came off the osmium. +2. And then there's actually just a 1 sitting on the osmium, so that must have come off the selenium. So it looks like it's a -1. And then you look at this, you go, okay, that might be all right. But there's actually an issue with those ion charges. So always go over to the selenium first. That's going to be the one that tells you, is the ion charge for selenium actually a -1? And that's atomic number 34 in the nonmetals. And you look and you go, no, it's actually a -2. So why the heck did we change it to a 1? Well, that's because this thing has been reduced. And if we took a 2 and we made it into a 1, that means we cut it in half. So we actually want to undo that by multiplying by 2. So osmium that 2 must have actually been a 4 because we divided it by 2, so now we want to multiply by 2. So there we go. And then if you can sort of see that swap and drop, the 4 would cross over, the 2 would cross over, and then they would reduce down to a 1 and a 2. So we know that -2 is indeed the ion charge for selenium. And then is +4 an option for osmium? It sure is. So to name this one, tricky because it's been reduced, this one is osmium. And we used the ion charge of 4, not 2. It looked like it was a 2, but it's actually a 4, which is IV, 1 before 5. And then Se is selenium, which becomes selenide. There's that IDE ending. So hopefully that made some sense. We'll definitely go over this again on Wednesday, so don't sweat it. What you can do for practice, if you have time, I have no idea how much time is left in your day, you can, in that nomenclature packet, now do worksheet number 2, which is just the back side of the front piece of paper. Worksheet 2, you can do numbers 1 and 2. So if you got a couple minutes left, give that a try. In addition to finishing off worksheet 1 with the naming, and then anything that's given you trouble, we shall review together next day. But thanks for playing along, folks. Thanks for taking the notes down. Give those worksheets a try, and if you get stuck, that's okay. Don't sweat it. We will chat next day. Have a great rest of your Tuesday. I look forward to seeing you tomorrow.